Hey guys, welcome to week 2 of eLearning. It's Miss Bisher coming to you from the island in my kitchen. I've decided this week that I would create a video instead of choosing videos other people have done, so that hopefully you feel the story of where we were in class and what we're doing now is a little bit more continuous. And maybe just seeing me do it will feel a little bit more comfortable than watching someone else's method of solving these problems. All right, so bear with me. I have my document camera, I have coffee, and my cat Boots. So I apologize in advance if he happens to jump up and walk across the table and try and sit on my computer. That is some of his favorite things to do. All right, I'm going to be sharing my screen and I'm going to be taking you to a PowerPoint presentation, just a couple slides that will help guide us in our conversation. I'm going to take you to some PhET simulations to help us visualize what's happening in these chemical reactions. And then we're going to work through some problems together. At any point in time, pause the video, get something to drink, walk around, do something else. If you need to write something down, pause the video. On my desk in front of me, I have pencils, I have my calculator, I have my periodic table, and I have my mole map from class. So if you don't have those, oh, and I have my science notebook. So I'll be writing things down with you. So if you don't have your calculator, pencil, periodic table, mole map, and your notebook, please pause the video, go grab those so that you have them ready when we need to use them. Right, so we're gonna jump on in. I'm gonna start by sharing my screen with you so that you can see what I'm seeing. All right. Okay, welcome to eLearning week 2. And so where we're at, when we were last together in class, we were talking about the families of reactions and how we could identify what family of reaction a substance belongs to, whether it was combustion, synthesis, decomp, single displacement, double displacement reactions, recognizing that all reactions in chemistry fall in one of those families. And if we know that, then we can use the properties of those reactions to predict what we think would form. So some previous skills that we're going to be building on, we're still using those ideas of predicting the products of a reaction. We're still remembering that the reaction is a chemical equation. The chemical equation is a scientific model, and that this model has to accurately represent the real world. So we balance chemical equations to remember that in the real world, compounds combine and rearrange to form new products. We're going to use train tracks to convert from one unit to the other, and we're going to use our mole map to remember that we can go from the real world of things we can measure, grams, into the measuring cup of the mole that makes everyone equal, and then into items too small to see, like atoms, molecules, formula units, or we can convert, if it's a gas, into the volume of a gas. So these are all previous skills that we were practicing the last time we were together. Some new skills that we're going to build this week is we're going to predict the amount of a product that can be produced or the amount of reactant consumed in a reaction. We're also going to predict which reactant is going to be completely used up. Who will limit the amount of product that we can form? Who will be our limiting reactant? And then we're going to use the amount of product produced in a reaction and determine the percent yield. We're going to give the reaction a grade. So all of the work that we do when we work with the chemical equation, that's all theoretical. In theory, this is what could happen. And then in the end, we're going to say, okay, we went into lab. We did the reaction. We attempted to make this product. Now, we actually made this much. How did we do? So that's what this last statement is. The percent yield is where we give ourselves a grade. And every reaction, no reaction in the real world is 100%. So even though we said we should be able to make X amount of grams, you're not really going to be able to make that much. So we'll always have less than 100% yield when we're looking at an equation. So chemical reactions in chemistry can be intimidating because they use compounds and formulas of things we're not familiar with. So I just wanted to remind you that chemical reactions happen around us every day. A reaction occurs when you're cooking. So this morning I made some eggs and a reaction occurred when I cooked those eggs for my breakfast. Didn't look quite this yummy, but you know, it was eggs. And inside of my body, while I'm working right now, that those proteins in those eggs are being broken down and they're being converted into chemical energy that my body can use. So chemical energy in the form of carbohydrates, fats, and proteins are being broken down through chemical reactions, and those chemical energy in those bonds is being stored in the compound ATP, and some of that energy is being released into the environment in the form of heat. So chemical reactions, they happen around us all the time. The ones we're going to do in our chemistry class are just a little bit different because they involve compounds, and those compound formulas can look different and uncomfortable and intimidating. But ultimately, that's all we're doing. We have a reactant, we're breaking it apart, we're making new products, and we're going to release energy along the way. All right. So we've modeled these ideas of reactants, products, and PhET simulation. We're going to jump in and look at this PhET simulation here. And the PhET simulation helps us visualize the amounts of things. So let's jump over to this PhET simulation. Okay. When I click on the PhET simulation, it brings me to this home page. The goal of the simulation is to recognize that all substances that form in set ratios. So we're going to start with, they always like to start with sandwiches. So we'll start with sandwiches. Here they're giving us the recipe to make a cheese sandwich. They're saying there's 2 slices of bread and 1 slice of cheese will make 1 cheese sandwich. This is the set ratio on how these things combine. Now, how much bread you have in the real world or in your example is probably going to be different. Right? In this example, we get to pick. So let's say that we have 8. We have 8 slices of bread, okay? Now the ratio tells me that you will make a sandwich every time you have 2 slices of bread and 1 slice of cheese. So if I have 1 slice of cheese, boom, I have the ratio for 1 sandwich. If I have 2 slices of cheese, now I have the ratio to make 2 sandwiches. Right now, how many sandwiches I can make is being limited by the cheese because I'm using all of it. There are no leftovers of cheese. The cheese is the limiting reactant. The bread is in excess. There's extra bread left over at this point. So here is my leftovers, or what we would call, these are the excess reactants. They're just chilling in your beaker, or in this case, in your loaf of bread bag on your counter, waiting to be used in another reaction. Let's look at meat and cheese. Let's erase these guys. Okay. For this equation, we're making a meat and cheese sandwich. They're telling us up here at the top that the ratio of how to make a meat and cheese sandwich is that if you need 2 slices of bread, you need 1 piece of meat and 1 slice of cheese to make a meat and cheese sandwich. So it doesn't matter how much you start with. Again, if we start with 8 slices of bread, you will only make a sandwich when you have the ratio of 2 slices of bread plus 1 slice of meat plus 1 slice of cheese. Okay, all of the problems, that's boots. All of the problems that we have looked at so far, we have just been balancing the equation. We haven't been asking the question of which one we'll run out of. We've always just given you amounts and said, use all of it. Actually, we didn't tell you anything. That's just what you did, right? So here we have 2 slices of bread, 1 slice of cheese, or excuse me, 1 slice of meat, 1 slice of cheese, poof, sandwich, okay? If I have more meat, doesn't matter. You don't have the right ratio of everybody else. You just have excess slices of meat. These numbers, the 2, the 1, the 1, these are the mole amounts. They are the cups or slices or pieces of bread. In our chemistry world, in our chemistry world, those coefficients, the fancy word for the number that goes in front of a compound, this coefficient tells us the ratio of molecules to make one molecule of compound, or the ratio of moles. This is the mole ratio. Okay, we're going to go to our periodic table, or excuse me, our mole map. Mole map. We're going to our mole map because we want to write this down. This is an important way that we can convert. I can convert or find out how much of something is used or how much of something is created if I know the mole ratio. All right, to our mole map. So here's my mole map. Here in the center of my mole map, I'll make this big here for you guys. Get me out of the way. I'll move myself over here. Okay. In the center of my mole map is the mole, the universal measuring cup. Okay. Here is my mole. On the right is the real world. This is the grams. This is what we're usually given in a problem. We have grams of sample. And remember how we had those extra boxes that we didn't fill out? Well, we're filling one out right now. This is called the mole ratio. This is the mole ratio. And the mole ratio can be used to convert between reactant and reactant, or reactant to product. Okay, well, how do we find the mole ratio? Well, the mole ratio comes from our balanced chemical equation. Okay, so how am I going to find this thing? Where will I find it? I will find it on the balanced chemical equation. Balanced chemical equation. So usually we've been writing examples of different ones. So let's write the example for making water. So we'll write this equation over here to the right. To form water, I know I will need hydrogen gas plus oxygen gas to form water. We'll say it's water vapor. These are my substances. We've been practicing writing compounds. So like this is element makes compound. This is a synthesis reaction. So the next step is you have to balance it. So here we have two hydrogens. Here we have two oxygens. Oh, only one oxygen. So in order to get the balanced equation, I have to put a 2 in front of water. Now this gives me 4 hydrogens. So I have to put a 2 over here. 2 hydrogens. So I have 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right. My mole ratio is the ratio of any of these substances compared to each other. So I can write several mole ratios or several relationships for this reaction. One example is I can say 2 moles of H2 will consume 1 mole of oxygen. So 2 moles of H2 are needed or will consume 1 mole of O2. Another mole ratio I could write, I could say 2 moles of H2 will form 2 moles of water. 2 moles of H2 will form 2 moles of water. And there's one more relationship that I can describe. I can also talk about how oxygen is related to water. So here we said how these two are related to each other. So the last mole ratio I could write is I would write 1 mole of O2 will form 2 moles of water. 1 mole of O2 will form 2 moles of water. Now, which ratio do I pick is completely dependent on the problem. So we always start by looking at the relationship, the reaction that we're doing. The second thing we do is we balance it. We have to have a balanced chemical equation. And then we can talk about, well, what am I starting with and what am I going to? This is the recipe. This is the ratio for forming any new compound. All right. So last week, that's what you practiced doing. You practiced doing some problems where we gave you starting amounts and then you converted into final compounds. So let's do some of those together. Well, this would be a great time to go into your science notebook, right? So we're going to go into our science notebook. We're going to go to our next blank page. So next blank page. Oh gosh, I actually ran out of papers. Here we go. So this is my next blank page. 31, 33, 34, 37, 39, 41. Okay. All right, so I'm on page 41. This is eLearning, week 2, and it's unit 7. Stoichiometry. That's Boots saying I want to go outside. But he doesn't really. Okay. eLearning week 2, unit 7. All right, here we go. So I'll solve these problems along with you. So eLearning, there's an I in there. Week 2, Stoic. Okay, lots of times we just abbreviate stoichiometry, we just say Stoic. So if you see that, just know it's just a shortened word because we're chemists and we're lazy. All right, so let's look at some reactions. Let's do this first one. We have lithium solid plus iron 2 sulfide solid yields Li2S solid plus Fe solid. Step 1, balance the equation. So I want you to pause the video and I want you to balance the equation. Okay, you probably didn't have to pause the video because I'm guessing you saw it was pretty fast. We've got 1 lithium on the left and we've got 2 on the right. So we're gonna stick 2 here and then everything else balances out. So let's say that I start with 4.5 moles of lithium, and we want to know how many moles of Li2S would form. So we're in theory world. We're in the mole map. In order to convert from one thing to another, we have to be here in the mole. Well, we are in the mole. So we start by writing down what we were given. We were given 4.5 moles of lithium. And the question says, if I know how much lithium I have, then how much lithium sulfide could I make? Well, the ratio says there's 2 moles of lithium for every 1 mole of Li2S formed. So we're in moles, so we can go straight from moles to the mole ratio. So we make our train track. We are converting out of moles of lithium, so the unit moles of lithium will go on the bottom. We are determining moles of Li2S, so that's what's going to go on the top, moles of Li2S. And I go to my equation to find the numbers. It says 2 moles of lithium, so the 2 moles of lithium makes 1 mole of Li2S on the top. Moles of lithium cancels. And the math says take 4.5 times 1 and divide by 2. So I'm going to grab my calculator. It says take 4.5 times 1, enter, and divide by 2. My problem had 2 significant figures, so I will keep 2 significant figures. So I'll round my answer to 2.3 moles. 2.3 moles of Li2S. So if I start with 4.5 moles, I'll end with 2.3 moles of Li2S. Now this is a great practice problem to just think about how to convert from one to another, but it's not realistic because we don't measure in moles in the real world. We measure in grams. We measure mass of substance and we produce things mass of substance. And we use the mole just like the recipe to figure out how are these things combining together. So let's do another example problem. And this time though, we're gonna start in grams of something and we're going to end in the actual world of grams of something else. So let's say that you start, so here was one. So here's our next problem. Let's say that you measure out 16.50 grams of lithium. And you want to know how many grams of iron can be produced. Right, so here's our question. 16.50 grams of lithium. This is what you've measured out in your lab. And you want to know how many grams of iron could possibly be produced. There's Boots is super interested in this. Okay, so we start by seeing, we write down what we're given. Okay, we're given 16.50 grams of lithium. Okay, and we want to go from lithium to iron, but we're in grams, and we cannot go to the chemical equation to find the ratio until we are in the same unit. So I go to my mole map. Here on my mole map, here are grams of the real world. It says in order to convert, you have to go from grams into the mole. Once you are in the mole, then you can go from mole of one thing to mole of something else using the mole ratio. Okay, so step one, we have to go from grams and convert into moles. When we convert from grams into moles, grams is the unit we're in, we're getting rid of it, so grams goes on the bottom. Grams of lithium in 1 mole of lithium. We say, well, how many grams are in a mole of lithium? I'm going to look that up. I'm going to go to my periodic table. I'm going to find lithium. Here's lithium. It says 6.94 grams is 1 mole. So 6.94 grams is 1 mole of lithium. Grams of lithium cancels. And now I'm in moles. And the mole map said I can go from 1 mole of a substance to a different substance using the mole ratio. So I'm going out of moles. So I'm going to get rid of moles of lithium. I'm converting to moles of iron. So here's moles of lithium. We're going into moles of iron. The reaction says 2 moles of lithium will make 1 mole of iron. So 2 moles of lithium will make 1 mole of iron. Moles of lithium cancels because they are diagonal to each other. And then we ask, are we done? Well, they want it in grams. We're in moles. We need 1 more step. I want to convert out of moles and into grams. I'm getting out of moles, so moles goes on the bottom. 1 mole of iron. And I want to know how many grams are in 1 mole of iron. So I go to my periodic table. I find iron. Here's iron. It says 55.85 grams is 1 mole. 55.85 grams of iron is 1 mole of iron. Every label that's diagonal cancels. The only label I'm left with is grams of iron. That's what I was looking for. The math says multiply everybody on the top and divide by the ones on the bottom. So let's grab our calculator and give this a shot. 16.5 times 1 times 1, oops, 1 times 1 times 55.85 divided by 6.94 divided by 2. The problem has 4 significant figures. I will give them 4 significant figures in my final answer. 66 point, keep the 6, 4, right, keep the 6, keep the 6, keep the 3, keep the 9, and then ask, does the 2 round up or fall off? The 2 falls off. 66.39 grams of iron. And box your answer. So last week, that was a skill that we were practicing, going from different units, either the measuring cup of moles or the real world of grams, and doing our train tracks to convert from one unit to the other. Okay, I'm going to put a couple practice problems up that on Schoology that I would like you to solve through, and then we're going to come back for part 2 And in part 2, we're going to try and do some more problems and find out which one do we run out of. See you soon.